So guys, this video is based on shear forces and bending moment, and in this video we are going to cover shear force diagram, bending moment diagrams, types of loads, types of beams. So let's start our video. Now beams. A beam is a structural member that is designed to support the applied load. It resists the applied load by a combination of internal transverse shear force and bending moment. In building, majority of loads are vertical and majority of usable surfaces are horizontal. So generally we are making beams as vertical in buildings. Now there are 3 to 4 types of beams. First one is cantilever beam. In cantilever beam, a beam which is fixed at one end and free at the other end is known as cantilever beam. As you can see in the here one end is fixed from here and the second end is free. We can apply forces, like in this example you can see at railway station they are making this type of structures or beams. So this one is cantilever beam. As you can see uh, this is one is the fixed end and here the free end. Now the second type of beams are simply supported beam. As you can see in this figure, a beam supported or resisting freely on the supports at its both end. So here the both ends are fixed, so they are saying as simply supported beam, and this the both ends are not fixed, but they are applying some supports. Because of these supports they are at same position, so we are saying as simply supported beam. Now the third one is fixed beam, and as you can see in this beam the ends are fixed in this beam. A beam whose both ends are fixed and it resists restrained against rotation and vertical movement, also known as built-in beam or in-cast-tree beam. So remember these three names of fixed beams. Now the fourth one is overhanging beams. As you can see here, the some parts are overhanging. If the end portion of the beam is extended outside the supports, then it's called overhanging beams. Now what are the types of loads we are applying? So as you can see in this figure, in this diagram, they are only applying point load, concentrated loads on the beam. Now in this diagram, in this figure they are applying uniformly distributed load, UDL, and these loads are similar throughout this beam. And the third one is uniformly distributed load, uniformly varying load. And here as you can see at starting point the load is 0 and now it's gradually increasing by increasing the length of beam, so they are called as uniformly varying load. So what are the effects come when we are applying these loads? So as you can see in this here, when we are applying forces or loads in a beam, then it try to make a curve shape. So we are saying the rod or the beam is bending. So as you can see in this figure, and now after applying some more forces, when the both ends are fixed, then it trying to shear. So we are saying at shear forces. So these are the two effects comes when we are applying forces. And now we are going to study about bending moment and the shear forces diagram. So here shear force and bending moment, where shear forces are is the algebraic sum of the vertical forces acting to the left or right of the cut sections. So we are saying that shear forces, and in bending moment is the algebraic sum of the moment of forces to the left or the right of the section taken about the section. So here there are some formulas, shear force and bending moment formulas. As we can see in this figure, this one is the cantilever beam with a point load. We are applying point load at the end B. Now we have to make the shear force and bending moment diagram. So how we can calculate shear force? So as we know, shear forces are the forces, those are our loads. So here as you can see, these loads are at downward, so shear force is positive and the bending moment is negative, as you can see by using this formula minus wx. W is the weight or load. Now we have to make the graph. So here fx is equal to plus w means the graph the diagram of shear force is in positive direction, and fx is equal to w. We have to take a dimension of w at positive direction. Now we will get a rectangle as the shear force diagram in cantilever beam with point load. And in bending moment diagram, we can calculate moment as minus wx means in negative direction, but here we can see there is a x term. It means it's a straight line. If we put all of this condition like at starting and the end condition, like at x is equal to 0, mx is equal to 0, so now here as you can see the bending moment is 0 at starting point. If we will take x is equal to L, means we will get minus WL here, maximum bending moment. So it graph like comes like this at a straight line, and as you can see in this formula, bending moment is negative, so in negative direction. So this is the way how they are making graphs or diagram. Now here in this example, there is a cantilever beam with uniformly distributed load. For UDL, how we can calculate shear forces? By using this formula fx is equal to plus wx, because this UDL is in downward direction, so we have to take it positive, but bending moment in this direction is negative. So for shear force diagram, this one is fx is equal to plus wx. If we put conditions at x is equal to 0, this point, then we will get fx 0, means at starting point from here we are taking shear force diagram from here, so we will get 0, and we will take, when we will take x is equal to L, then we will get fx is equal to WL at a straight line, so we will get WL at this point, so we will get this graph but in positive direction. So this one is the shear force diagram, but for bending moment diagram we will get formula mx is equal to minus total load on right portion into distance of center of gravity of right portion. So how we can calculate mx bending moment? So mx is equal to minus wx into x by 2 is equal to minus wx square by 2. So here we are getting x square term, it means parabola, but in my in negative direction. So put condition x is equal to 0, we will get mx 0, means this position we will get mx as 0, but if we put x is equal to L, then we will get mx is equal to minus WL square by 2. So at this point we will get mx as minus WL square by 2 in negative direction, and this graph is parabolic because we are getting x square term in this formula. So this one is this bending moment diagram. So this is the how they are making graphs. And now at third condition, cantilever with gradually varying load. So how we can make diagram? So for shear force diagram, we know the formula fx is equal to wx square by 2l. So we are getting here x square term, it means it is an parabola but in positive direction. So here you will get this as by putting this condition, and for bending moment we will get formula as minus wx cube by 6l. We are getting x cube term, means it is in cubic but in negative direction, then we will get this diagram. So thank you. I hope you understood about the cantilever beam, how we are making graphs of shear force diagram and bending moment diagram. If you don't understand anything, then please comment below, and please solve some numericals based on shear force and bending moment diagram. Then you will understood the all of these concepts.